here we have Mat 1033, Chapter 3, Section 7, which is linear inequalities. It's the last section in the chapter. Here's example 1. We have 2x minus y less than 6. We need to graph this. So the first thing I do is subtract the 2x over, then multiply through by a -1, which means I have to flip the inequality sign. This becomes positive, this becomes positive, this becomes a minus. Now I'm in slope-intercept form. Come down here, and remember that because this is just greater than, or if it was just less than, it's a dashed line. If it was less than or equal to or greater than or equal to, it'd be a solid line. Make sure you understand that. So I come down here, I start with the y-intercept first. I start at -6. Slope is 2 over 1, so I go up 2 and over 1. I got my 2 points. So there's my dashed line. Now, this says it wants all the y's that are greater than the line. So all I have to do is look at where the line intersects the y-axis. Anything below this line is less than, or y is less than the line. Anything above it, or y is greater than the line. This says y is greater than the line. So we want to shade everything above it, and that's what I've done here. We go to example 2. Here we have 3x greater than or equal to y. All I did was flip sides. So I brought the y over here, the 3x over here, which means I got to flip the sign as well. Also, I put a +0 to remind me that my y-intercept is 0. So I plot my y-intercept as 0. The slope is 3. I go up 3 and over 1. This is a solid line because this is less than or equal to. Again, I'm concerned with the y's that are less than the line. Any y's here are greater than the line. Any y's here are less than. So I'm shading below it. Next two examples, example 3 and example 4, deal with graphing what we're going to call compound inequalities, where we're graphing two inequalities at one time. And if the word is an and, it's an intersection. If the word is an or, it's a union. Let's talk about intersection. So intersection is where these two graphs will come together. So I'm graphing one in purple, one in red. And wherever I see purple and red together, that's my solution. There is no numerical solution. There's only a graphical solution here. Okay? So the first one, x is greater than or equal to 1, is the same thing as x equal to 1. And we learned from sections back that when we have x equals a number, it's a vertical line going through that number on the x-axis. So here, and it's equal to, so it's a solid line. So here it is right here going through 1. We're looking for all the x's greater than the line. Here's the line going through the x-axis. These are the x's less than. These are the x's greater than, so I'm shading purple all through here. Next one, I have y greater than or equal to 2x minus 1. Start with -1, go up 2 and over 1, draw my line. Again, this is a solid line. This is looking for the y's greater than the line. Here's where the line crosses the y-axis. The y is greater than the line or above it, so we're shading here. Now, here's the area where the red and the purple come together. Because this is an and, this right here is our solution. Now, when you give me this as an answer, if you don't give me this and this, not a problem. But you had better give me the shaded area that's a solution. You had better show me that it's the shaded area that we need. Also, remember, and I can't say this enough, make sure you understand, greater than or equal to, less than or equal to, solid line. Greater than, less than, dashed line. If you don't do that, I will mark it wrong. Here we come to example 4. Now this is a compound inequality again. But this has the word or. The word or means union. It means we take everything in the graph except stuff that's repeated. So for or, we take everything in the graph. Okay? Except what's repeated. Now if we come back to this one here, if this had been an or there, the answer would have been all the red going to all the purple. We wouldn't have worried about this right here. Alright, so this one here, we have the equation x plus 1/2 y greater than or equal to -4. First thing I do is subtract the x over, then I'm multiplying by 2, no flipping the sign because this is positive, so I have y greater than or equal to -2x minus 8. This right here, y is less than or equal to negative 2. Remember, we talked about this in early sections. When y equals a number, it's a horizontal line going through that number on the y-axis. This is less than or equal to. So let's start with this graph. Here's my horizontal line at negative 2. It's in purple. It's a solid line. It's less than, so it's shading below. There's in red, y greater than or equal to negative 2x minus 8. Start with negative 8, go down 2 and over 1. There's my red line. This is everything above the line, so we have it here. So if I were looking for and, my solution would have been right here, right in this area here where the red and the purple come together. But because it's an or, our solution really is all of this right here. All of this. But we don't have to say this twice, just once. Again, let me say it again. If this were an and in between here, our solution would have been where the red and the purple come together, which would have been here. Because it's an or, we're concerned with everything. So we take as our answer everything. Remember, in these particular problems, linear inequalities, your answer is going to be a graph, not a numerical answer.